Date is date is the uh date is the 22nd of March 2026. Time now is 7:03 a.m. 7:03 p.m. So I've got the Mighty Mary model here. I've got a video of it. So create, destroy, repair, renew, build and break. The end of the month for verification system. So, for example, you have a node attractor, which is basically a very kind of something you can pull on a downloader, but it's really for the downloading system, make it for the attractor model. So you're gonna have attracting or something. You're gonna have a pro packet P given S, so implies D. Where did the data? And again, P given D implies S, which is state. So you get a node and a start port. But because the node and the start port have information, you have a node up, node down, node left, node right, north strange, north charm, presenting the four consumptive position state. But basically you get orientation, you get a direction, orientation and direction, and you're gonna use the download artifact. So it's the network, it's the downloader, but the downloader is gonna work. So you're gonna have the charm divided by the strange, which basically a charm is basically anything that's up, down, up, spin up, spin north. Basically have an vector component for up, or they have a charm over the string. So you're gonna have a charm, which is basically anything that's up divided by anything that's down. But the charm is priority, which is in the string. But the goal I want to make is using the loader. So how does this work? So you have 512 bytes of data, and you have node east, south, and west. So you're gonna have as artifacts some kind of you're gonna have a 3-layer system. You're gonna have something that's cached, a cache, cache 512 byte of data, and that's to the power of 9. To the power of 9 can be divided by 3 to 9 divided by 3 is 3. So if you have 3 bytes, you don't have another 3 bytes of data, but 3 bytes of data signifies if you get 3 bytes of data, you have 3 bytes. We have a system of knowledge. You have a cache. Say the cache stores 4 bytes of data. Looking at 4. So you get so you have the cache stores 2 bytes of data. 2. So you have 2 to the power of 9, which is 512. 412 bytes of data, and 2 to the power of 9 represents the blocks. So the 9, so 2 represents binary number 2, binary number 2, 2, binary number 1 or 0, 1 and or 0, 1 or 0, and I'm gonna have 9. Now 9 represents the blocks of memory, so 9 blocks. For some reason I have a second here. For example, if you have an artifact that has memory, they are alphanumeric and you can download it via some kind of alphanumeric index, for example, alphanumeric representation. So you're gonna have A0, A1, A2, B0, B1, B2, C0, C1, C2, and these are addresses. So if you have some kind of downloading artifact on A0, A0, B0, and C2, in the worst case, in the worst case scenario, you can have the worst case. So you have to go to the single unit. If you have a thing that's Z0, so so for example, you can have an index on A0. So A0, B0, C0, all indexes one time for the download. So it compares artifacts and downloads what's needed. And that's what Magnetic downloads do. You compare artifacts and download what's needed, because what's needed is basically have an address, and that address is a block of memory over a region, span, a region of like a span, like skipping a span of a width of a region, memory region, and that memory continues to be probed. So it asks for the data, and the downloader system has to maintain do it. So I'm not sure how this works, but here we have a system of download system, but you're gonna have kind of a problem. So if you have 212 bytes of data, you have 512 bytes of data. The 512 bytes have a ball rotation. So A0, AB1, and C2 are the worst case because they are on the axis of the system. So you cannot really download this in a linear fashion. You cannot just pull the memory address and wait for the download. So if you can basically, it might be sense to address memory addresses. And memory addresses are non-linear, so there are blocks of memory that are non-linear. Because 512 bytes can be represented linearly via conjugate model. So A0 is a pointer to memory address 0 to 1, and you're gonna have a system representing that system. You're gonna have so we're gonna collect the system. So you're gonna steal it. So you get the system. I'll know what it does, but you have a repel and attract. Like repelling of a system. You get the property of repel and attract, which are just the magnetic principles of electromagnetic systems, and you're gonna have a state machine that enumerates something that attracts, it's just something that repels, it's just something that halves. So you're gonna have a system output of magnetic principles. So you're gonna have a half, 1, a quarter, 2, a sixth, 3, an eighth, and 4, and this represents the rotation of the system. So if you're downloading a half, you have you already have a mapping between a half and a 1. And if you have downloaded a quarter, you have a mapping of a half, a quarter, and 2. Because this quarter and 2 are two memory regions of the download. So because it's Magentic. So if you go in minus a half, basically it wasn't a bearing axis. So if you're downloading a half, you're downloading 45 degrees, you're already falling 45 degrees already. If you're a half of 90 degrees, 45, you're already 45 degrees, and you have one download. You're observing one download, you're going to download 1 and 1. Basically, it doesn't get verified based on my system. So, the system has to be magnetic because it's on the strike. So you can be fast, not faster, but based on electromagnetism. So, so you have a half mapping to 1, a quarter mapping to 2, a sixth mapping to 3, an eighth of the download mapping to 4. And this represents the full output of downloading 512 bytes of data. If the rotation change, if you get minus, you are basically gonna have two. You're gonna have a minus and positive. So basically, I'm using bearings to model this, and the model of bearing system ensures that it's magnetic. So it can download something magnetically instead of based on the state machine. So basically, magnetic on the inverse are the strain. You get the inverse system based on strain and entire model. So you can verify the magnetic system. You can verify the electron artifacts too. For example, you have the machine Wi-Fi. E is a DFA. Q is a set of basically Q epsilon Q Q0 F is final state and delta is the transitions, and get magnetic DFA, which is S psi M0 magnetic 0, G is configuration, and D is rotation. Orientation. So you get rotation in the magnetic rotation. So you get everything, because it wasn't the fourth transformation rotation. But you are doing transformations on system. So instead of rotation, you get orientation. Instead of rotation, you get orientation. Instead of reflection, you get mirror. You get asymmetry. You get symmetry. You get symmetry. Instead of reflection, you get symmetry. Instead of reflection, rotation. Basically, you compute. Instead of enlargement, you get if you're doing enlargement, you do scalar. You do enlargement. If you do scalar, you get space. You get some kind of size, the bytes of memory. That's bytes of 3 sets of bytes. You're gonna have 3 pumps issues. You're gonna have 3 sets of data, of enlarged memory. So you're gonna have 3 sets. But if this tripod, you're gonna have yes, no, and maybe based on the example. So the goal is to have the system magnetically represent state machine via bijection. So the bijection will basically be verified through the process of downloading the artifact over the SIGI protocol. But it's magnetic, so it's basically magnetic electronic, magnetic electronic machine with the case of electromagnetism, magnetism, a system of a core, a system of non-linearity or non-polarity. I don't know what I can do it now, but I'm not sure about how to do this properly. So you can get orientation, displacement, and elevation. But you're gonna have also the create, destroy, or half create, half destroy, which is basically half create, a quarter create, a sixth create, an eighth create, and 1/10 create. This the conjugate mode of binary system, as it propagates waves. Because the more information you have, the more it can be noise for create, destroy, build or break, or big break up based on all the binaries of the system. What connects, build, renew, and repair. It does work, but it doesn't work. I don't know what it's. This is very theoretical for me, but the magnetic is what I want to formula to do first. Because if you can formula the magnetic, I can know what to retrieve. Basically, it's more of a basically it's a download by need. So it retrieves. So it just retrieves the artifact. So it's not being corrupted. So it treats corruption in the mechanical state of everything, and everything works on rotation. So rotation or like a moving. It's really a magnetism downloader. On installer. So I built my own downloader before, but I don't know how to download it via proxy. But I don't know how to do it again. So I have to try to build this magnetic downloader to see how this downloader puts up for anybody on the internet. So download the HTML file via web request. But if also you need to pull something or push or pull something via magnetic system. Magnetic systems. I don't even know how this is gonna work, but if you post something, kind of pulling something from the cloud, so based on the yes, no, and maybe three centralized server that index it around. Thank you for watching this video now, or listening to this audio.